In this video, I will give you an overview of the workings within the safety risk management, or the SRM component of the safety management system. First, remember the foundational difference between the definitions of hazard and risk. A snowy runway, for example, is a hazard. Slipping off the snowy runway is a risk. Plowing the snowy runway is a control. Let's analyze the risk of slipping off of the snowy runway. We get the risk, or the risk index, by comparing the likelihood with the severity and putting those two values together to give us the risk indicator. First, we'll analyze the probability or the likelihood. This will be in our example here, it's going to be a qualitative analysis. In many cases, you have enough statistical or engineering information to determine likelihood quantitatively, that is, using numbers, actual statistics. And that is generally better if you have that option. In our case, it will suffice in our example here just to work through the process, show you the overall how the process works using qualitative data. So your text, the ICAO Safety Management Manual, and several other documents, advisory circulars and such, give great guidelines and suggestions on how to categorize likelihood. It is not a requirement to use, and this is important, it is not a requirement to use these exact definitions in your particular SMS program. An operator can use whatever definitions work for their company, but the principles remain the same. For this example, we're going to use the definitions from ICAO. So, a snowy runway. A snowy runway is a hazard. It has the potential to do harm. Key into that word, potential. Potential should be a trigger to this being a hazard. It hasn't happened yet, but it has the potential to do so. However, as long as the airplane is tied up, no harm will come related to the snow on the runway. The airport, though, wants to open, but we do not want airplanes sliding off the runway because that doesn't work very well for our purposes. With our classifications of likelihood, our definitions here, and our values, what is the probability that an airplane landing on an unplowed runway might slide off? I'm going to choose occasional. This is value 4. It's a bit conservative. It probably could be frequent, but let's go just for our illustration purposes of occasional. You may have chosen a different classification or a different value, but that's why it's recommended that when risk is analyzed in real life, we do it with a team or a safety committee. So now that we have analyzed the likelihood, or we've determined the likelihood criteria, it's time to analyze severity. What is the extent of the damage or harm? What are the consequences should the risk be realized? We will use the suggested criteria from ICAO for this part of the illustration as well. Now, severity in this illustration is a little more difficult to assess because the severity really depends a lot upon your equipment. If a Citabria slipped off the side of the runway due to snow versus if an Airbus A320 slipped off the side of a runway due to snow, the difference in the severity would be significantly different. So in some cases it may be embarrassing, and in some other cases it may be really, really bad. For the sake, though, of our discussion, let's classify severity as major. That is a value of C. Once we have determined likelihood and severity, we put those together to determine a risk index. So we had a severity of C, like Charlie, likelihood of 4. Put those together, we get a risk indicator of 4C. Well, what do we do with that? We plot it on a risk matrix. Here's a risk matrix. This is an option of the risk matrix from ICAO. In our case, 4C. 4C is where we fall on the risk matrix, and that indicates moderate risk. Now, let me pause just for a moment and show you this process through the flowchart, or through the SRM process flowchart. We've already designed and analyzed the system. That assumption was made before we started this video. So we identified a hazard. The hazard was snow on the runway. The process of determining the risk index through analyzing severity and likelihood criteria is called risk analysis. Once we have the risk index, or the risk indicator, then we can assess the risk. We can make a decision whether or not to accept the risk. Don't get these two confused. We conduct risk analysis to determine the risk and evaluate where to plot the risk on the matrix. After we have identified the risk, then we can conduct the risk assessment to decide what to do with it. So going back to our scenario, we determine that we do not want to accept the liability of this moderate risk, so we need to control it. As such, our risk assessment is we need to control the risk, so we continue working through the SRM process. We decide to institute a control and plow the runway. In doing this, what do we reduce? Severity or likelihood? Let's see. Previously, we determined that we would occasionally have excursions from the runway if we did not plow it. After plowing, though, the likelihood of a runway excursion due to snow on the runway is really either improbable or extremely improbable. For the sake of our illustration, let's call it extremely improbable, since we have removed the snow from the runway. So we've removed the hazard. If it continues to snow and stay a little bit slippery, that's a different aspect, and we'll address that in a little bit. But let's say we plowed the runway, we removed the snow from the runway, therefore the likelihood of an aircraft landing and excursioning or getting off of the runway or slipping off the runway is extremely improbable. So now let's go to the severity criteria. We said previously that the severity of a runway excursion due to snow would be a major consequence. Well, what's the new severity of an aircraft slipping off the side of the runway? I suggest to you that it would be the same. Now follow me here. We reduce the likelihood of a runway excursion due to snow by plowing the runway. However, if an excursion occurs, it would still be the same severity. We have not mitigated that. So severity in this case remains the same. However, the overall risk index is still impacted, and let's talk about why. With a new likelihood of 2, with a new likelihood of 1, and the same severity value of C, like Charlie, we have a new risk indicator, which is 1C. When plotted on the risk matrix, 1C indicates green or acceptable risk. In this scenario, our second trip through the SRM component, after controlling the risk by plowing the runway, we plowed the runway in the risk control, and we took another trip down through the SRM component. We analyzed the risk, and then we assessed it. We made an assessment. And we assessed the risk to determine that it is acceptable to open the airport. After accepting the risk, we move it into the safety assurance component. And we're going to talk about that a little bit later. But in the safety assurance component, we continually monitor that hazard and that risk for the system itself for new hazards. And we'll get into that a little bit later. For now, I wanted to, just to drive the process home just a little bit more, here's another flow chart by ICAO that illustrates what we just did. We start by identifying the hazard. We conduct risk analysis by evaluating the likelihood and severity, the probability or likelihood and the severity criteria, and then we assess that risk for whether or not we want to accept it, whether we can tolerate it, if you will, risk tolerance. Our first trip through the SRM process with an unplowed runway, the risk was too great. We could not tolerate the liability, so we instituted a control. We plowed the runway, and we reassessed the risk then. We moved back down through that entire process, and we determined in post-control analysis that the risk was low enough that we would accept it. So after the second trip down through the process, we accepted the risk because we had controlled it. After accepting the risk, then, the process moves out of the SRM component and into the SA component for continuous monitoring.